Thanks for joining me for this video. We will be discussing measures of dispersion or measures of variation. So variation is how much something varies from one thing to the next. So that's what this is about. So one way to measure dispersion is the range. So the range is simply the difference between the maximum value and the minimum value. So you just subtract largest minus smallest and you get your range. That tells you the difference in your extremes. The next common way is standard deviation. So a standard deviation is a measure of variation based on measuring how far on average each data value deviates from the mean. So a standard deviation, you'll know the mean, and it tells you how far your value is from the mean. So it can tell you it's slightly above the mean, it's slightly below the mean, it's really far above the mean, etc. So it's kind of judging based on, again, how far it deviates from the mean. A few characteristics of standard deviation: it's always positive or zero. In other words, it's non-negative. The only way it's zero is if every single data value is exactly the same. So if every data point is exactly the same, in other words, if you had 10 people living in a town and every single person made $20,000 a year, there's no deviation. There's no change. Everyone has the same salary. So the standard deviation would be zero. However, if even one person changes, then there's a deviation from the norm. So it would always be positive. Standard deviation has the same units as the original data. So if your data is measured in dollars, then the standard deviation is also in dollars. Standard deviation, like the mean, can be highly influenced by outliers. So if you have an extreme value, let's take our town of 10 people making $20,000 a year, and then we move in a new neighbor, and that new neighbor makes $20 million a year. Well, that one person who makes $20 million a year is going to highly skew the mean and the standard deviation. To compute standard deviation, here are the steps that you will go through. First, since you're comparing everything to the mean, if they don't give you the mean of the data set, you need to find the mean. After that, you will subtract the mean from each data value. Then you're going to square that deviation. So the difference that you find, you're going to square it. That squaring makes every difference positive. Then number 4, you're going to add all those squared deviations together. Number 5, you're going to divide either by n or n minus 1. If you have the whole population, you're going to divide by n, which is the number of data values. If you have a sample, then you're going to divide by n minus 1. And then the last step is to square root that result. So let's try some of these. So here's our example. We want to find the range, the mean, and the standard deviation. So before I go any further, I just want to give credit here to Scottsdale Community College. They have an open resource textbook online. It's free. College Mathematics First Edition. That's where this example came from. If you're interested in looking at more examples or having a deeper understanding of the topics, feel free to check that out. So our example, we have a price or 5 prices of peanut butter from different stores. They're listed here. We want to find the range, find the mean, and then find the standard deviation. So the range is simply largest minus smallest. So the smallest value is $3.29 and the largest is $3.99. So to find the range, you're going to do $3.99 minus $3.29, and you will see you get 70 cents. So the range, as long as you know how to do it, very easy. You just subtract. No problem there. Okay, find the mean. So remember that the mean is the sum of all the data values divided by the number of values that you have. So we're going to add up all of our prices. So $3.29, $3.59, $3.79, $3.75, and $3.99. And we're going to divide that by 5. And let's see what we get for that. So for the sum on the top, I got $18.41. And then when I divided that by 5, rounding appropriately, I got $3.68. Okay, so finally we want to find our standard deviation. So your first step is making sure you already have the mean, which we found in part B. Now what you want to do is find the difference between each jar of peanut butter, each data value, and the mean. So you're going to subtract the jar of peanut butter minus the mean. So for that we'll get $3.29 minus $3.68, and we get negative 39 cents. Then we have $3.59 minus $3.68, and we get negative 9 cents. Then we have $3.79 minus $3.68, and we get 11 cents. Then we have $3.75 minus $3.68, and we get 7 cents. And then we have $3.99 minus $3.68. So $3.99 minus $3.68, and we get 31 cents. So I've taken every single data point, we had 5 of them, and subtracted the mean from each data point. Notice if the data point was smaller than the mean, I got a negative. So it means it's smaller than the mean. I got a positive when the data value was larger than the mean. Now we have negatives here, but remember our next step is to square all of these differences. So now I'm going to square all of these differences. So you find the difference between the data points and the mean, then you square those. So 39 cents times itself is 0.1521. 9 cents squared is 0.081. 11 cents squared, 0.0121. 7 cents squared, 0.0049. And then 31 cents squared is 0.0961. So here are all the squared differences. So let's just scroll up and remind ourselves of the process here. Number 1, find the mean. We did that in part B. Number 2, subtract the mean from each data value. We did that. Number 3, square each deviation. We did that in blue. Number 4 is add the squared deviations. So that's what we need to do next. So number 4, add all these up. When I did that, I got 0.2733. Okay, so again, let's go look and see what we need to do next. Number 5, divide by n if you have the whole population, or divide by n minus 1 if the data is from a sample. So we're going to assume that there are more than 5 stores carrying this peanut butter. So this is a sample. So we're going to divide by n minus 1. Remember, n is the number of data values. So in this case, n is 5. So if you have a sample, n minus 1 would be 4. So we're going to take what we got are sum of the squared deviations, and we're going to divide by n minus 1, which is 4. So divide by 4. And when I did that, I got 0.068325. And then the last step is number 6, compute the square root of the result. So number 6, we want to find the square root of that. So when I push square root, I get point, and now this is in the same measurement as our data points. So our data points are dollars, so we want to round to the nearest cent. So I get 0.261, so that would round to 26. So the standard deviation is 26 cents.